Today we're going to be talking about measuring angles and arcs of circles. So first we want to look at what a central angle is. And a central angle is the angle that is made up in the center of our circle. So if you look right here, this is circle B. Remember, we call it circle B because its center is B. And so there's actually our central angle would be angle ABC. And so that's some angle right there. And so a full circle makes up 360 degrees, so this is going to be some number that's less than 360. Now, the reason we need to know that is because all of the angles, all the central angles in our circle have to add up to 360. So here it shows you that angle 1 plus 2 plus angle 3 all add up to 360 degrees. And we can use that information to solve problems. So in example 1, it says find the value of x right here. Well, we know that GFH is 130 degrees. We know that JFH is equal to, that means 90 degrees. Remember that little box means 90 degrees. And then there's x, and we don't know what that is. So what we're going to do is we're going to say, well, 130 plus 90 plus x all has to add up to 360 degrees. Okay, so we combine our like terms right here. So that's going to be 220 plus x is equal to 360. Subtract 220 from it, from both sides, and we find that x is equal to 140 degrees. And you can check your answer by plugging that into your equation to make sure it equals 360. Here's a couple guided practice problems to try now. Now, an arc is no longer the central angle, is what we're looking on the inside, but an arc is along the circle. And our arc corresponds with the angle that we have. So if you look down here, there's a couple different types of arcs. There's a minor arc, there's a major arc, and there's a semicircle. Now minor arcs are going to be less than 180. So if you look right here, if this x degree is less than 180, this is a minor arc AB. And we denote it looking like this. So the measure, and then it's like a little squiggly line over AB. Okay, AB is what makes it a minor arc. Okay, it's equal to the measure of the central angle ACB going through the center. A major arc is going to be when it's greater than 180. Now you'll notice in this one right here, it goes through a point D and then over to A. So we have to label our major arc using that letter D as well. So it's major arc ADB. And the way we could figure that out is if we know what little AB is right here, this is going to be 360 minus that little minor arc. And finally, the last one, semicircle. You've known that for a long time. That's when it's half of the circle. Okay, so that would be 180 degrees right there. Okay, so if you look right here, okay, if JG or GJ is the diameter of circle K, identify each arc as major, minor, or semicircle, then find its measure. So if I look right here, I'm looking for arc J or GH right here. Okay? Well, it corresponds with angle 122. So this is going to be a minor arc, and it's going to be equal to the measure of GH is going to be equal to 122. Notice I don't put the degree sign with it. It's just equal to 122. Next one, okay, letter B. The measure of GLH. GL all the way to H. Now that's going to be a major arc because it's the rest of the circle other than the 122 degrees. And so what we're going to do then is we're going to take 360 minus 122, and we find that then the measure of arc GLH is going to be equal to 238. And I found that just by taking 360 minus 122. All right, last one. Okay, I'm going to get rid of all the other drawings on here, okay, just so we can look at a fresh circle. And we're going to look for GLJ. GLJ. Well, I look right there, and this is a straight line because it says that the diameter across is GJ. So that's straight across the diameter. So everything in between here is just going to be 180 degrees. So this is going to be a semicircle. And so then the measure of arc GLJ is going to be equal to 180. Okay? Here's a guided practice problem that you can try now. So we can look at this and we can find the measure of each arc. So we're looking for CD in this one. Okay, right there. It says it's 18% of our circle. So we're going to take 18% as a decimal times 360 degrees. Okay, and so that is going to be 64.8. That's the length of that arc right there, 64.8. All I did is take 18% times the 360 degrees. Next, we're looking for BC. Okay, well, BC, same thing, 18%. Same thing, so it's going to be 64.8. Don't even have to do the math on that one. You do not. Okay, now, we have a postulate 10.1 that says the measure of an arc formed by two adjacent arcs is the sum of the measure of the two. Meaning, if I know what xy is, and I know what yz is, then xz is going to be the same as both of them added together. Makes sense, right? Alright, so if I look at example 4 right here, okay, I'm looking for the measure of arc AED. AED. Okay, so we know that AE is going to be arc length 63. We know that ED is going to be arc length 90. So the measure of arc length AED is going to be 63 plus 90, which is 153. Okay? Look at the next one. ADB. Okay? So ADB. So that means if I'm going ADB, it means I start at A, I go all the way through D, and then all the way through B again. Okay? So, what I can do then is I say, okay, so this is 63 right here. Okay? I know that this is 90, right? I also can see that BE itself, the whole thing BE, right here, I'll draw in purple, is going to be 180 plus this 63. So this is going to be equal to the 180 semicircle plus the 63 that we already have. So the measure of arc ADB is going to be 240. There it is, right there. Here's a couple more problems you could try also. Now the last thing we want to do is find arc length. Now arc length itself is the ratio of the length of the arc to the circumference of the circle, and the ratio is the degree measure of the arc to 360. So essentially, we create this proportion all the time. Okay? So L over 2 pi r is equal to x over 360. Or, what we can do is we can find this right here. Okay? So arc length is the distance between the endpoints along the arc in linear units. Since it's a proportion of the circle, its length is a fraction of the circumference. So this is what we want to look at all the time. Alright, so let's look at this example right here. Now that I have a radius, my arc length has to be found using that important number. So, this one right here, 75 degrees. Okay, so I'll set it up like this. I like to do the degrees first. So 75 over 360 is equal to the arc length over 2 times pi times the radius, which in this case is 4. Okay, so I'm going to cross multiply. Okay, I'm going to cross multiply. Actually, I'll fill in my number first. So 75 over 360 stays the same. Okay, 75 over 360 is equal to L over, and then 2 times, I'll use 3.14 for pi, times 4 is 25.12. So I cross multiply, right? And I end up getting 360L is equal to 75 times 25.12 is going to be 1,884. divide by 360, divide by 360, and I find my arc length is equal to 5.23 inches. Okay? Let's try example B. Okay? So that one right there, okay, our semicircle is 180 all the way across right here, right? And so since this is 30 degrees, this missing side is going to be 50 degrees. So we say 50 over 360 is equal to the arc length over, now this time they give us the diameter of 10. Remember, diameter times pi is also the circumference. So it'd be 3.14 times the diameter of 10, which you could do also. 3.14 times 10 is going to be 31.4. Now I can cross multiply. I get 360L is equal to 50 times 31.4 is going to be 1,570. Divide both sides by 360. And I find that L is going to be 4.36, and that was centimeters. Okay. Last one, example C. Okay. Last one, example C. I'm looking for this arc length right here. Right? So, if I'm looking for that arc length right there, I'd say 75 over 360 is equal to L over 2 times 3.14 times 6. And so I get 75 over 360 is equal to 2 times 3.14 times 6 is going to be L over 37.68. Okay? Cross multiply. I get 360L is equal to 75 times 37.68. 2826. Divide by 360. And I find that L is equal to 7.85. And that would be inches.